Hi dear students, once again welcome back to my channel SKSN Chemistry Coaching. Myself Khaseem Shaik. Today I am going to discuss about variation of molar conductivity with concentration from the chapter Electrochemistry. Variation of molar conductivity with concentration which is also known as DEBYE-HUCKLE equation. DEBYE-HUCKLE equation. Students, conductivity first we will take. Conductivity which is represented with the Greek alphabet which is known as kappa. Conductivity is defined as conductance of 1 centimeter cube electrolytic solution. On the other hand, molar conductivity which is represented with the lambda m, this is known as capital lambda m is conductance of 1 mole of electrolytic solution. 1 mole of electrolytic solution. So whatever it may be the concentration, we need to consider a solution which contains 1 mole of electrolyte. So let us see what is the change in conductivity and molar conductivity with the change in concentration. When the concentration decreases, what happens to the conductivity and the molar conductivity? Let us see. For example, if it is a concentrated solution, number of ions per unit volume will be more. We are considering a concentrated solution, then the number of ions per unit volume is more, right? Assume these are dots indicates these are the ions. For example, this is electrolyte like NaCl solution. We are considering NaCl aqueous solution. So when it is a concentrated solution, the number of ions per unit volume it will be more, maximum it is, right? So when the number of ions is more, the conductance will be more. We are talking about conductivity, the change in conductivity with the decrease in concentration. Next time, to the same electrolyte, what we have done is we have added more amount of water, so it will become as diluted solution. Of same electrolyte we are considering NaCl aqueous. Then what happens with the increase in dilution, the number of ions per unit volume it will decreases. Anyway, conductivity is a conductance of 1 centimeter cube electrolytic solution. So when more amount of water is added, the concentrated will becomes as a diluted, then the number of ions per unit volume, less number of ions it is present. Ions will decreases. less number of ions. Here per unit volume we can put more amount of ions here, more number of ions. So with the increase in dilution, the increase in dilution, the number of ions per unit volume decreases. K also it will decreases. So what is our final conclusion is, as the concentration decreases, that is dilution increases, the number of ions per unit volume decreases, hence the conductivity decreases, right? So on the other hand, molar conductivity is given by the formula lambda m is equal to K into 1000 divided by molarity. Capital M indicates molarity. So here molar conductivity is defined as conductance of 1 mole of electrolytic solution, right? Let us consider a concentrated solution. First case, let us consider it is a 1 mole of electrolyte is present in 1 mole of NaCl in 1 liter of water, which is concentrated solution. The number of ions we can indicate it with the dots. The ions plus negative and positive ions indicated with the dots like this. Next time when we are doing dilution, assume same amount of electrolyte is present in 10 liter of water, diluted solution, 1 mole of NaCl in 10 liters of water. In both the cases, students, we need to consider the conductance of 1 mole of electrolyte only, because molar conductivity itself it is defined as conductance of 1 mole of electrolyte. So conductance of all the ions we have to consider, that is 1 mole of Na plus as well as 1 mole of Cl minus, right? So when it is concentrated, the number of ions we have to consider, the conductance is for all 1 mole of Na plus as well as 1 mole of Cl minus. 1 mole of Na plus, 1 mole Cl minus. Whereas when we add more amount of water to this, again we need to consider the conductance of 1 mole of Na plus, 1 mole of Na plus and 1 mole of Cl minus, because molar conductivity itself it is defined as conductance of 1 mole of electrolytic solution, right? So here NaCl, when we take 1 mole of NaCl gives 1 mole of Na plus and 1 mole of Cl minus. So when the dilution increases, what happens is, being it is a strong electrolyte, next we will discuss what is a strong electrolyte, weak electrolyte. So when the dilution increases, the effect of one ion on its counter ion decreases. The effect of positive ion on negative ion, anion, will decreases. When it is a concentrated, each ion is close to the other counter ion, plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, plus. These are closer to each other in the concentrated solution. So then the effect of one ion, that is effect of cation on the anion, it will be more when it is a concentrated solution. Similarly, the effect of anion on the cation, it will be more, so that all the ions are not free to move in the solution. When it is a diluted solution, when it is diluted, there is a lot of gap between the ions, so that each ion is free to move. When the mobility will increases, then the conductivity also increases. So with the change in concentration, that is, if you decrease the concentration, conductivity kappa value will decreases, because conductivity is electrolyte 1 centimeter cube electrolyte. On the other hand, molar conductivity, all the cases, if it is concentrated or diluted, we need to consider for 1 mole of electrolyte. So when the dilution increases, the effect of one ion on its counter ion decreases, then each ion is free to move in the solution. So when the movement increases, mobility increases, conductance also increases. Students, molar conductivity depends on two factors. Molar conductivity depends on two factors. One is concentration. Second one is nature of electrolyte. Concentration effects just now we have discussed. That is, as the concentration decreases, mobility of ions increases. Molar conductivity increases. So when the concentration is decreasing, dilution increases, then the effect of cation on the anion decreases. Similarly, the effect of anion on the cation also decreases. When the effect of one ion on its counter ion decreases, then the mobility of ions increases, hence the conductivity increases. So molar conductivity will increases with the increase in dilution, right? Second factor is nature of electrolyte. Electrolytes can be classified into two types. One is strong electrolytes, other one is weak electrolytes. Strong electrolytes which ionizes completely in the aqueous medium. Strong electrolytes are the electrolytes which ionizes 100% in aqueous solution. Generally, all salts are considered as weak electrolyte. Generally, it means some exceptions may be there. In general, all salts are considered as strong electrolytes. Strong acids and strong bases are considered as a strong electrolytes. On the other hand, weak electrolytes are which does not ionizes completely in aqueous medium. Example, weak acids weak acids and weak bases. Weak acids and weak bases. Students, molar conductivity depends on two factors. One is the concentration, other one is nature of electrolyte. So, as the concentration decreases, means dilution increases. Mobility of ions increases because the effect of one ion on its counter ion decreases. When the effect of one ion on its counter ion decreases, each ion is free to move in the solution. So that is mobility of ions increases, molar conductivity increases. Second factor is nature of electrolyte. Electrolytes can be classified into two types, strong electrolyte and weak electrolyte. Strong electrolytes are which ionizes 100% in aqueous solution. Example, generally alls are considered as a strong electrolyte, strong acids and strong bases. On the other hand, weak electrolytes are which does not ionizes completely in aqueous medium. Example, weak acids and weak bases. Now let us discuss about the graphs of molar conductivity of strong electrolytes and weak electrolytes. Strong electrolytes. Strong electrolytes like salts, NaCl, KCl, strong acids like HCl, H2SO4, NaOH, bases like NaOH, KOH. For these strong electrolytes, we can plot a graph by taking the square root of concentration on x-axis, where C is the concentration, by taking square root of C on x-axis and lambda m value on the y-axis. So we can get a graph like this, straight line. We will get a graph that is a straight line. Okay. If you want to get molar conductivity at infinite dilution, so this is theoretical values. This graph is based on the theoretical values. We will get a straight line like this with a negative slope. Slope is negative value. So that means in the reverse we can study this graph. This on the x-axis, when we are moving from left to right, concentration value is increasing. As the concentration is increasing, what happens? The molar conductance is decreasing. These values on the y-coordinate, y-axis, that values are decreasing. So that means with the increase in concentration, lambda m value decreases. In the reverse, you can study this graph with the decrease in the concentration in the reverse. For example, assume that here the concentration is 0.8 molar, 0.7 molar, 0.6 molar, like that it is present. So at the 0.8 molar concentration, the molar conductivity is a corresponding value on the y-axis. This is, assume this is a lambda 1. For example, capital lambda, you take lambda 1. When the concentration is decreased to 0.7, that means dilution is increased, then the corresponding value on the y-axis indicates that is a molar conductivity lambda 2. Which one is greater from this? When we go upwards, the value of the lambda m value is increasing. So here it is very clear, lambda 2 is greater than lambda 1. So which case the concentration is less? That lambda 2 case corresponding concentration is 0.7. So that means as the concentration is decreasing, right to left we have to study this graph. As the concentration is decreasing, that is dilution is increasing, molar conductivity increases. Molar conductivity increases. We are studying for the strong electrolytes. Whatever the concentration for strong electrolytes, ionization is 100%. So that means if you take a concentrated solution or diluted solution for the strong electrolytes, all the concentrations, ionization is 100%. What is the reason to increase the molar conductivity with the dilution is that the effect of one ion on its counter ion decreases. The effect of one ion on counter ion decreases. You can write it as the concentration decreases, that is dilution increases, the effect of one ion on its counter ion decreases. Hence, molar conductivity increases. Students, for the strong electrolytes, whatever the concentration of the electrolyte present in the solution, that ionization is 100%. But why that molar conductivity increases with the dilution is, as the concentration decreases, that is the dilution increases, the effect of one ion on its counter ion decreases, and some mobility. So mobility increases and some molar conductivity increases. So to get molar conductivity at infinite dilution, we should extrapolate this graph, extending the graph till it will cut the y-axis. This y-intercept, which can be obtained only by the graphical method, that is called as lambda m naught or lambda m infinite, which is known as molar conductivity at infinite dilution. Students, here infinite is not any number. So for example, if you want to obtain lambda m by the practical method, it cannot be obtained, because here the corresponding value here, when we want to obtain that lambda m value, that x coordinate should be 0. That means there is no electrolyte is present, but there should be some electrolyte. So molar conductivity at infinite dilution indicates that is the dilution where each ion is free to move in the solution at that particular condition. The molar conductivity is called as molar conductivity at infinite dilution. So the relation between molar conductivity and the concentration is given by DEBYE-HUCKLE equation. Lambda m is equal to lambda m infinite minus a into square root of c. This equation is known as DEBYE-HUCKLE equation. DEBYE-HUCKLE equation. This equation is very important. They will not ask any questions, but the graph and this equation is important from this part. In this equation, lambda m is a y coordinate, that is molar conductivity. Square root of c is the concentration, which is a x coordinate, and lambda m naught or lambda m infinite is molar conductivity at infinite dilution, and a is any constant, right? This negative sign indicates slope is negative. Negative sign indicates as the concentration increases, molar conductivity decreases. Now let us consider for the weak electrolyte. Like acetic acid, for example, we will consider, which is a weak acid. CH3COOH gives CH3COO minus plus H plus. Being a weak electrolyte, it will attain equilibrium with its ions. So from the Ostwald dilution law, we can write alpha, degree of dissociation is equal to square root of Ka by C. So from this graph, it is clear that as concentration decreases, dilution increases, alpha value increases. So students, with the increase in the concentration, when we increase the concentration, alpha decreases. When we decrease the concentration, dilution increases, so alpha increases. So here for the weak electrolytes, when we increase the dilution, for example, 1 mole of electrolyte is present in 1 liter of solution. Other case, 1 mole of electrolyte is present in 10 liters of the solution. One mole of electrolyte, 1 mole in 1 liter, 1 mole in 10 liters. So with the increase in dilution, for example, you take plus minus, like that, cations and anions are present. So being a weak electrolyte, for this molecules also exist. Molecules I am representing with the dots. Molecular form as well as ionic form will exist for the weak electrolyte in the solution. Right? When we increase the dilution, according to Ostwald dilution law, same amount of electrolyte is present, 1 mole, but water here it is 10 liters, then ionization increases. Plus. As the ionization increases, the number of ions in the solution increases. As the number of ions increases, conductance will increases. And distance also increases. When the dilution increases, distance also increases. So mobility increases. Here for the weak electrolyte, molar conductivity with the dilution increases due to 2 factors. One is, with the increase in dilution, degree of dissociation increases. As the dissociation increases, the number of ions increases in the solution. Similarly, the distance between the ions increases. So the effect of one ion on its counter ion decreases, mobility increases, hence the conductance increases. Students, for the weak electrolyte, as the concentration decreases, that means that is dilution increases. Molar conductivity, lambda m increases due to 2 factors. The first one is, according to Ostwald's dilution law. Ostwald's dilution law. For the weak electrolyte, we can write like for the weak acid we take alpha is equal to square root of Ka by C. So concentration C and degree of dissociation alpha both are inversely proportional to each other. So when the concentration is decreasing, the dilution increases, the alpha value degree of dissociation increases. As the C decreases, alpha increases, that is ionization increases. The number of ions increases. Hence the molar conductivity increases. Lambda m increases. One factor is, according to the Ostwald dilution law, that is alpha is equal to square root of Ka by C. As the concentration decreases, that is dilution is increasing, alpha increases. So when the degree of dissociation increases, that is ionization is increasing, the number of ions increases, and the molar conductivity increases. Second factor is, with the decrease in concentration, the effect of one ion on its counter ion decreases. So mobility increases. Hence molar conductivity increases. Whereas in the case of strong electrolyte, earlier we have discussed, with the increase in dilution, only one factor is coming into act, that is with the decrease in concentration, that is with the increase in dilution, the effect of one ion, its counter ion decreases. So mobility increases, hence molar conductivity increases. So for the strong electrolyte, earlier we got a graph like this, square root of C versus lambda m, straight line with the negative slope, we are getting like this. To get molar conductivity at infinite dilution for the strong electrolyte, we need to extend this graph till it cuts the y-axis. This y-intercept lambda m naught is called as molar conductance at infinite dilution. Here infinite is not a number, it is a constant. Infinite dilution indicates the dilution at which each ion is free to move in the solution. The adequate amount of water, that sufficient amount of water is present, so at which each ion is free to move independent of its co-ion. Electrolyte, the molar conductance changes linearly with the change in concentration. This is for the strong electrolyte, which is given by DEBYE-HUCKLE equation. The change in molar conductivity with the concentration is given by DEBYE-HUCKLE equation. Lambda m is equal to lambda m naught minus some constant A into square root of C. Whereas for the weak electrolyte, the molar conductivity will increases with the increase in dilution. That is because of two factors. One is ionization increases, the other one is the effect of one ion on the counter ion decreases, hence the mobility increases. This we can draw a graph like this by taking the square root of C on the x-axis and lambda m molar conductivity on the y-axis. Now because of two factors, what happens is, with the increase in dilution, the reverse we have to see, with the increase in dilution, there is a sharp rise in the molar conductivity. In the reverse we have to see, right to left, as the concentration is decreasing, dilution is increasing, there is a sharp rise in the molar conductivity value. So from the graphical method we cannot able to calculate the molar conductivity at infinite dilution. When we try to extrapolate it, the graph, it will go parallel to the y-axis. So for the weak electrolyte, we cannot calculate the molar conductivity at infinite dilution by graphical method, but which can be calculated by using Kohlraasch law, right? Students, thanks for watching. If you like this video, please do subscribe.